Assalamu alaikum dear students. Welcome in lecture 14. In this lecture we are dealing with a simply supported beam, and this beam is basically is also a simple beam, okay, but the only trick part of this beam is this inclined support. Clear? So now we need uh, to analyze this simply supported beam, and we need to determine the reactions at this point and this point and this point. Okay, so this is the example. Okay, and let's start that how we will deal with this example. Clear? Okay, so let's start that how we will deal with this example. Clear? So let's make sure about your units, that is feet. Clear? Your unit should be feet. We will use beam template. We have one span. Clear? We have a 24 feet span. We don't need this grid spacing. Okay, and remove this window and let's see. Okay, this is the beam having hinge, having ruler. Okay, units are okay. Now we will need to rotate this joint. Okay, we need to rotate this joint. Clear? So you see here that this joint is basically rotated by an amount of equals to 60 degree. Clear? So you can see that this is your supporting surface, or you can say plane, and the plane is basically rotated from horizontal by an amount of equals to minus 60 degree. Okay, this is minus 60 because it is rotated in anti-clockwise direction, not in clockwise direction. So let's see. Select the joint, assign joint local axis. Clear? We need to rotate the joint, okay, from about this is the coordinate system. Okay, so we need to rotate this joint about y-axis. Okay, not about x-axis and not about y-axis. Clear? Sorry, z-axis. We need to rotate the joint by an amount of 60 degree. Okay, so there we will insert minus 60 degree. Clear? So this is the joint. Okay, now we will assign the loading, assign frame loading, distribute it, make sure this is setting to 0, modify. Okay, feet, add to existing loads, force. You need to apply loading in this case in the direction of global axis z. Okay, or gravity direction. Okay, absolute. Now at a distance 0, you have intensity of 2 kilonewton per meter, and at mid span, that is 12 feet, you have an intensity of 3 kilonewton per meter, and at a distance of 24 feet, that is the end point, you have an intensity of again 2 kilonewton. Okay, loading is symmetrical. So this is the loading at the midpoint. Basically at the midpoint you have a clockwise movement. So point load, okay, feet, select movement, global, and the movement is applied about y-axis. Okay, here you can see the movement is applied about y-axis because this is x, this is z, and this is y-axis. Y-axis are those axes which is passing through the screen, you know. So that is perpendicular to the screen, okay, to the plane, okay. So therefore, the loading which we will see in there, that is 600 feet, is applied about y-axis. Clear? So we will select here y-axis. The amount of the load is it acts at a 12 feet distance, and the magnitude is 600 feet. Okay. So the load are assigned. Clear? Now if you are interesting to 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 check the loading, whether the loading is assigned or not, so go to display, show load and frame loads. There you have two options. If you want to see your movement, then select this one and OK. And XZ plane or XY plane, YZ plane, you don't see the movement. To see the movement, you need to select 3D view, and this is the movement, and this is in this direction, so therefore this is clockwise. Okay, again XZ plane. And if you want to see your distributed load, select frame and select this option, and you will see for again. Now the loading are assigned, joints are assigned. We will analyze the structure. Model do not run. Run now. Save the project, and let's say these are the reactions, you know. So let's check the reactions, that whether the reactions are okay or not. So we have FB equals to this reactions, and you must know once you rotate your support, so there will be, you know, once you rotate your support, then the normal force will be perpendicular to your plane. Clear? This will be now your reaction, and that is 110. And similarly the other reaction is AX. So there will be AX. Okay, the reaction, you know, due to the rotation of this support, there will be horizontal thrust, and that thrust is AX. Clear? And there will be a vertical action, okay, that is 5 kips, and this is, I think so, this is 95 point something. Clear? So let's see. So that is 95, that is 110 and 5. So the reactions are okay. So this is the procedure, that how we analyze a structure or a beam having inclined loading or inclined supports. Clear? So this is the end of this lecture. If you have any question, any suggestion, any comments, please share your comments on my email, on my channel. That is the name of Misbahullah Engineer. Watch the video and enjoy. Thank you.